right, everyone, get ready, because today we are taking a deep dive into some serious cutting-edge tech.
Oh, yeah.
This is a programmable photonic latch for optical data storage.
Okay.
Now, if you're like, what?
Yeah.
Just try to imagine a world where your computer runs on light,
Okay.
not electricity.
Wow.
It sounds pretty wild, right?
Yeah, that's...
But this is what this research is hinting at. Faster, more energy-efficient computing.
Right.
And that goes for everything.
Yeah.
From AI to sensing, and even beyond that.
So what's so interesting about this is that it really tackles a major roadblock in optical processing.
Okay.
We've been using light to transmit data.
Right.
Which is super fast.
Uh-huh.
But then we get stuck with electronic memory for storage, which is so much slower.
It's like having a race car that's stuck in a school zone.
Exactly.
All that speed, but it's got nowhere to go.
Yeah.
So
yeah.
How does this photonic latch thing actually work?
So think of it like a light switch, right?
Okay.
But it flips on and off incredibly quickly to store information.
Got it.
But instead of your finger,
right,
it's controlled by light signals. And here's the kicker.
Yeah.
They built this thing using silicon photonics.
Okay.
Which basically means electronics, but with light.
Okay, wait, hold on.
Yeah.
So they created a light-based memory unit, but they're using the same material that's in our everyday electronics.
That's exactly right.
That's mind-blowing.
It's one of the most exciting aspects because it is silicon-based.
Right.
This technology has the potential to be integrated into existing manufacturing processes, which would make it much more scalable and cost-effective than other experimental technologies.
So this isn't just some lab experiment, right?
No.
They actually have a working model.
They do.
Oh, wow.
They demonstrated this photonic latch using a programmable silicon photonic platform, put it through its paces, with simulations, real-world testing, and the results are very, very promising.
Okay, you got my attention.
Yeah.
How fast are we talking here?
So the memory unit operates at a speed of tens of picoseconds.
Okay.
Put that in perspective.
Yeah.
It's millions of times faster than the blink of an eye.
No.
And significantly faster than the most advanced digital systems that we use today.
Okay, that's insane.
Yeah.
But what does that speed actually translate to for the average person? Like, will I finally be able to stream my cat videos in 8K without a single buffering hiccup?
Well, while faster cat videos are definitely on the table, the implications go far beyond that.
Okay.
This kind of speed could revolutionize fields like artificial intelligence.
Oh, wow.
Leading to breakthroughs in machine learning, data processing.
Okay, now we're talking.
Yeah.
And speaking of speed,
I
read something about this wavelength division multiplexing.
Yeah.
Or WDM. What's that all about?
So WDM is like having multiple lanes on a highway, right? For data.
Got it.
It allows different wavelengths of light to carry data simultaneously, which boosts capacity and efficiency. And the really cool part is that this new memory unit is designed to work seamlessly with WDM.
So they're not just building a faster car.
Right.
They're creating a wider, more efficient highway for the data to travel on.
Exactly.
That's incredible.
Yeah.
Does this mean we could potentially have entire data centers running on light in the future?
That's the ultimate goal.
Wow.
And because each of these memory units has its own independent light source, you can actually scale up the system without losing any power.
Wow.
So imagine data centers that are not only lightning fast, but also incredibly energy efficient.
Okay, you have officially got my inner tech geek doing cartwheels.
All right.
We are talking about a complete paradigm shift in how we store and process data.
Right.
But I'm curious, are there any potential downsides? Yeah. Is there anything about this silicon photonics approach that could hold it back?
That's a great question.
Yeah.
And one that researchers are actively exploring. So while silicon is abundant and cost-effective, it does have some limitations. For example, silicon isn't the best material for generating light. So that's an area where further innovation is needed.
So there are still some hurdles to overcome?
Yeah.
But the potential here is immense.
It is.
Before we dive into the specific applications of this technology, let's take a step back and make sure we understand the key concepts at play.
Absolutely.
We've talked about the limitations of current data storage, the need for faster and more efficient processing, and how this silicon-based photonic latch offers a potential solution. We also touched upon the role of WDM in maximizing data capacity and efficiency.
Right.
Okay.
Yeah.
Now that we have a good grasp on the fundamentals, let's shift gears and explore the exciting potential applications of this technology.
Sounds good.
Where do we go from here?
Right.
What areas are you most excited to see this impact?
One of the most promising applications is in the field of artificial intelligence.
Okay.
With the speed and efficiency offered by this new technology, we could see significant advancements in machine learning, data analysis, and more.
Okay.
But that's just the tip of the iceberg.
All right. I am on the edge of my seat.
Okay.
Let's dive deeper into those applications.
Let's do it.
And explore how this photonic latch could change the world as we know it.
Yeah, so we were discussing the potential impact of this programmable photonic latch technology.
Yeah.
And I think it's time we explore some specific areas where this could be revolutionary.
Yeah, I'm particularly fascinated by the implications for artificial intelligence. We talked about how this tech could supercharge large language models like ChatGPT.
Right.
But what about other AI applications? What else could this change?
Oh, the possibilities are vast.
Yeah.
Imagine, for instance, the impact on image recognition. With faster processing speeds, AI could analyze complex images in real time, leading to incredible advancements in fields like medical diagnostics.
Hold on. So you're saying doctors could diagnose diseases more accurately?
Right.
Potentially even earlier?
Yeah.
Just because AI can process images faster?
Exactly.
That's amazing.
Yeah. Think about the impact on autonomous vehicles.
Okay.
Self-driving cars would be able to react to changing conditions in a fraction of the time, making them safer and more efficient.
Got it.
And security systems could identify threats more reliably, enhancing public safety.
Okay, now I'm starting to see the bigger picture. We're not just talking about faster computers.
Right.
We're talking about a fundamental shift
in
how we use technology to solve real-world problems.
Exactly.
All this speed and processing power must require a ton of energy.
Right. That's a critical point.
Yeah.
Currently, data centers are massive energy consumers, which is a concern for both the environment and businesses' bottom lines.
Yeah.
But this new technology has the potential to significantly reduce energy consumption.
That's a huge deal. How does using light instead of electricity actually make that much of a difference?
So by using light for both processing and storage, these photonic memory units could dramatically reduce the energy needed to run data centers. They could operate at a fraction of the power that conventional data centers require.
So we're talking about a more sustainable and cost-effective approach to data management.
Right.
It sounds like a win-win for everyone.
Yeah.
Are there any other fields
There are.
where this technology could have a major impact?
Absolutely.
Okay.
The benefits extend far beyond AI and data centers. Right.
Think about telecommunications. Imagine a world where data can be transmitted and processed at the speed of light.
Wow.
With virtually no lag.
No more buffering symbols.
Exactly.
Sign me up. But seriously, what would that kind of speed unlock for things like internet connections and streaming services?
It would revolutionize the way we connect and communicate.
Okay.
We'd experience incredibly fast internet speeds, seamless video streaming, and virtually lag-free online gaming. It would be a completely different digital landscape.
That's mind-blowing. What about high-performance computing?
Yeah.
Those are the supercomputers used for things like climate modeling and drug discovery, right? How would this impact those areas?
Those supercomputers rely on immense processing power to tackle some of humanity's biggest challenges with the speed and efficiency of this new technology.
Okay.
We could see groundbreaking advancements in those fields. So scientists could potentially develop life-saving drugs faster.
Right.
Understand the universe better, and even predict natural disasters more accurately.
Yeah.
This technology really does sound like a potential game changer.
It's important to remember that we're still in the early stages of development, but the potential is enormous.
Okay.
Even fields like sensing technologies could be transformed.
Sensing technologies. What do you mean by that?
Think about sensors that collect and analyze information in real time. Things like environmental monitoring systems or even wearable health trackers. with faster data processing.
Okay.
These sensors could provide us with more accurate and timely insights.
So we could monitor pollution levels with greater precision.
Exactly.
Predict structural failures in buildings before they happen.
Yeah.
And even detect early signs of health problems with our smartwatches.
Yeah.
This is incredible, it sounds like. This technology could have a positive impact on almost every aspect of our lives.
It certainly has the potential to be a transformative force.
Yeah.
But it's important to approach this with a balanced perspective.
Okay.
Every technological revolution comes with its own set of challenges and considerations.
That's a good point. It's not all sunshine and roses, right?
Right.
What kind of challenges do you foresee with this technology? What should we be thinking about as this technology evolves?
One major hurdle is the integration of this technology into existing systems.
Right.
It's not a simple plug-and-play solution. It will require significant investment and collaboration between researchers, engineers, and manufacturers to make it a reality.
So it's not like we'll be seeing light-speed computers on store shelves next week?
No.
It's going to take time and effort to make this a widespread reality. What other challenges might we face?
Another critical concern is data security and privacy.
Right.
As we move towards a world where data is transmitted and processed at the speed of light, we need to make sure that our information is protected from cyber threats.
That's a crucial point. We don't want to sacrifice security for speed.
Right.
It sounds like a lot of thought and careful planning need to go into the implementation of this technology.
Absolutely. We need to be proactive in addressing potential risks and challenges.
Right.
It's also important to consider the economic implications of this technology. On the one hand, it could create new industries and job opportunities.
Right.
But on the other, it could lead to job displacement in certain sectors.
So while we're celebrating the potential benefits,
Yes.
we also need to be thinking about the potential impact on the workforce.
Exactly.
And how we can ensure a smooth transition for everyone.
Open discussions and strategic planning are essential to mitigate potential negative impacts on workers and create opportunities for retraining and education in this new landscape.
We're not just talking about a technological revolution, but a societal one as well.
That's precisely it. The development and implementation of this technology will have far-reaching consequences. We need a holistic approach that considers not just the technological aspects, but the economic, social, and ethical implications as well.
While we marvel at the speed and efficiency of this new technology, we need to be mindful of its broader impact on humanity. It's a powerful reminder that technology is a tool, and how we choose to use it will ultimately determine its legacy.
This has been an incredibly insightful conversation.
It has.
And I feel like we've only scratched the surface.
Right.
But before we wrap things up, one more question.
That's been on my mind.
All right.
We've talked about the potential of this technology to augment human intelligence. But what about the philosophical implications? As we develop increasingly powerful and efficient computing systems, what does it mean for our own cognitive abilities? Are we destined to be surpassed by the machines we create? We've been exploring this incredible programmable photonic latch technology and its potential to revolutionize everything from AI to data centers. But before the break, was asking what all of this means for human intelligence. As these computing systems get more powerful and efficient, are we on the verge of being outpaced by the very machines that we are creating?
That's a question that has been debated for decades. And one that this new technology certainly brings to the forefront. You know, it's natural to wonder if we're on a path for some kind of singularity where AI surpasses human intelligence.
It's definitely a thought-provoking concept. And honestly, a little bit unsettling. But I'm curious to hear your perspective on this. Do you see this as a threat? Or is there a way for humans and AI to coexist and even collaborate?
Well, I think the key here is to remember that technology is a tool. Like any tool. It can be used for good or for bad. And its impact ultimately depends on how we choose to wield it. So while it is true that AI is becoming increasingly sophisticated, I believe it's more likely that we'll see a future of collaboration rather than competition.
So instead of fearing AI as a replacement for human intelligence, we should be looking at it as a way to augment our own abilities.
Exactly. Imagine a world where we can seamlessly interface with AI, leveraging its speed and efficiency to solve problems that are currently beyond our reach.
So like what kinds of problems are we talking about?
Think about fields like scientific research, where AI could analyze massive data sets and identify patterns that would take humans years to uncover.
That's an incredible thought.
Yeah.
Instead of being threatened by AI, we could be working hand in hand with it.
Exactly.
To unlock new levels of understanding and innovation. It's almost like giving our brains a turbo boost.
That's a great analogy.
And it's not just about problem solving. AI could also help us to enhance our creativity.
Oh, absolutely.
Imagine artists collaborating with AI to generate new forms of art.
Yes.
Or musicians using AI to compose groundbreaking pieces of music. The possibilities are endless.
They are.
It sounds like we're on the cusp of a truly exciting era.
Yeah.
Where human ingenuity and artificial intelligence combine to push the boundaries of what's possible. But with all this talk of advanced AI, we have to consider the ethical implications as well. How do we ensure that these powerful technologies are used responsibly and for the benefit of humanity?
That's a crucial point.
Yeah.
And one that researchers and developers are increasingly focusing on as we build these powerful AI systems. We need to embed ethical considerations into their very core. We need to ensure that they align with our values and don't perpetuate existing biases or inequalities.
So it's not just about making AI smarter and faster.
Yeah.
It's also about making it more ethical.
Yes.
And aligned with our human values. That makes a lot of sense. We've been discussing the potential benefits and challenges of this technology. But I'm also wondering about accessibility. Will this be something that only benefits a select few? Or will everyone have the opportunity to experience the advantages of light-speed computing?
That's an important question, and one that we need to be mindful of as this technology develops. It's essential to ensure that the benefits of light-speed computing are distributed equitably and that we don't exacerbate existing digital divides.
So we need to be thinking about things like affordability, infrastructure, and education to make sure that everyone has the opportunity to participate in this new era of computing.
It's about creating a future where this technology empowers everyone, not just a privileged few. It's about ensuring that everyone has the chance to benefit from the advancements we're discussing today.
This has been an incredibly thought-provoking deep dive.
It has.
And I want to thank you for joining me on this journey.
It's a pleasure.
We've covered a lot of ground.
We have.
From the technical details of this groundbreaking technology to its potential impact on society, the economy, and even the future of human intelligence.
It's pretty amazing.
Before we wrap things up,
I
want to leave our listeners with a final thought to ponder. We've talked about the potential of this technology to speed up AI. But what other breakthroughs are on the horizon? What new possibilities will emerge as we unlock the power of light-speed computing?
That's a great question to consider. The future is full of potential. And I believe we're just scratching the surface of what's possible with light-based computing. It's an exciting time.
It is.
To be witnessing these advancements.
It is.
And I'm eager to see what the future holds.
So stay curious, keep learning, and join us next time for another deep dive into the world of cutting-edge technology.